Okay, so let's do the last part, which is the decoder. And let's take a look at the decoder and notice that of the outputs here, it's a little bit different from one hot encoding because it's actually one cold encoding. All of the outputs are going to be high except for the one corresponding to your inputs. And so um, what you need to have is you need to have E2, E1 and E2 need to be at ground, and E3 needs to be at ECC, and then A0, A1, A2 correspond to your 3-bit number, with A2 being the most significant bit. So this is 0, 0, 0, and then reading from right to left, 0, 0, 1, and then 0, 1, 0, and then 0, 1, 1, 1, 0, 0, and so forth. So A2 is the most significant bit. And so, like, if I look at the third to last row, high, low, high, so that's 1, 0, 1. So that is 4 plus 0 plus 1, that's 5. So that means output 5 is going to be low. So when I have number 5 as the input, then output 5 is low. So I'm just going to grab this so that I will have it handy. And then this is our chip diagram. Get all the pins. I did. Okay, and then we have our truth table that we already made. Right here. I think I copied it to this page. I did. Okay, so now let's do this as a decoder. So let's take a look at what we have. So if we want to take, okay, so if R is A2 and S is A1 and T is A0, we need to have ground to E1 and E2, and of course to ground. We need to have VC, I should have done that in black. We need to have VCC, so this is your high voltage. We need to have that to VCC, and we need to have it to E3. And then we're going to have switches. R, S, and T are going to be switches. And map R to A2 and S to A0 and T, R to A2, S to A1, and T to A0. And then our output is going to be, so when RST is 0, that gives us an output of low 1, 0, 0. So we want the not of that. So we need also a not. The not is 1, 2, 3, 4. It's this one, 7, 4, LSO4. 1, 2, 3. What happened to my page? Okay, so on the not gate, 1, 2, 3. So that's our input. That's going to be the output that we're going to want to AND to something else. And then also seven. We'll want the not of 7. We'll have the output from pin 4. This is a NOT gate that I've got right there, which is 74 LSO4. And pin 8 needs to be ground. And pin 14 needs to be VCC. And so we took care of those inputs, and we have these inputs, and now this will take so if we have 5, so if 5 is low and U is high, so we would take not 5, so 5 and 6. And I'll need an AND gate. And then our other one, that's 4. So here's what I'm trying to do. So I've got the decoder. I have R, S, and T coming in. It has outputs 0 through 7. I know that no matter what U is, for 0 or 14, I'll get an output, 0 or 7, I'll get an output of low. So I take the knots of those. For 4 and 5, I want the knot of those, but I need it to be ANDed with U. And then I would need the OR of all of these things. Okay, so let me draw this a little neater. So I've got my multiplexer. I've got my NOT gate. And I have an AND. I'm going to have an OR. I don't know why I'm bothering to copy all this. Okay, let's try this again. So this is my NOT gate right here. This one is my 3-input AND. And this one is my 2-input OR. And this is my decoder. So I have ground, and ground also has to go into E1 and E2. I have VCC. And I need VCC to go into E3. I need the outputs from 0 and 7 to be complemented. I need the outputs from I need R to go to A2 R should be a switch, S should be a switch. I have that backwards. R should be a switch going to R2, S should be a switch going to A2, and T should be a switch going to A0. So there's R, S, and T. U is going to be another switch. Actually, I'll put U down here. I need to get the NOT of, I believe it was 4 and 5. So I'm going to take the NOT of 4 and 5, and I'm going to AND those with U. It's a 3-input AND gate, so I'll just put a 1 into the third input. So that'll give me the NOT of whichever one that was, and then I will take the NOT of this one, and I will also AND it with U, and I'll get its third input here. So this is the AND of the NOT of the output of 4 and U, and the NOT of the output of 5 and U, and so those are coming out in 1Y and I got that one. Yeah, so I actually wanted the VCC to go to 2C right there. Okay, so now I have my outputs. So the things that I need to OR together are going to be 1Y and 2Y. So I'll OR those two together. I will also OR together my other two outputs that I got from way back here. Okay, and then I'm going to OR those two ORs. And then this finally will be my output. Logic monitor. So on your circuit diagram, which I thought I drew right here, so this is the NOT gate, so that's a different one. So here, this would be your circuit diagram. So we'd have the decoder, and those went into pins 3, 2, 1. This is already taking too much time. Maybe easier for me to do it like this. Okay, so these are the pins that you're going to use on the decoder. So pins 1, 2, and 3, those map to the switches that you have for T, S, and R. Pins 4 and 5 are E1 and E2, they map to ground. Pin 6 is E3, that maps to VCC. Pin 8 is ground, that maps to ground. Pin 16 is VCC, that maps to VCC. And then of your outputs, the ones you're going to use are 15, 11, 10, and 7. Okay, so next we'll look at a NOT gate. We'll see the pins that we'll use on the NOT gate. So we're going to take the NOT of this, and we're going to take the NOT of this, and we're going to take the NOT of this, and we're going to take the NOT of this. And then in this diagram, when I did that, I had the knots. I had 7 was 2, and 0 was 1, and 5 was 5, and 4 was 6. So these went into, so this would be in our NOT gate, that's 1 and 2. So this is 1, pin 1 coming in, pin 2 coming out. So I use 2. So that's pin 3 coming in and pin 4 coming out. And for 5, that's pins 11 and 10 coming out. 11 coming in, 10 coming out. And for 6, 13 coming in and 12 coming out. So on my NOT gate, I'm using pins 1, 3, 11, and 13 as inputs. 1, 3, 11, and 13 as inputs, as well as the NOT gate will also have VCC and ground. I didn't draw the entire pin there, but you would also have to make sure that you put ground and VCC on it as well. Okay, and then we're going to have a 3 input AND gate. We have 2 3 input AND gates. And on our 3 input AND gate, 1, 2, 13. So that would be gate 1. Pin 1 is the output from there. Pin 2 is U, and 3 is VCC, and our output 1Y is 12. And then we'll use the second AND gate, and our inputs U is going to be for 4. So that is pin 4. That's a 4. And 3. This will be pin 3. So pin 3 is the output from the NOT gate. Pin 4 is the switch from U. And pin 5 is VCC. And your output is 6. And then you'll have 2 OR gates. So the inputs to one of these OR gates are going to be the outputs from the NOT gates. So those will be 4 and 5. So that's pin 4, that's pin 5. And then the outputs from these AND gates are 1 and 2. So 1 and 2. And then so that's the first OR, that's the second OR. This is output 3, this is output 6. You're going to put those right back into another OR gate. You're going to put them into 12 and 13. And then your final output is going to be pin 11. And that you'll attach to a logic monitor. So you have to pick 2 of the 3 that we did to implement in the lab. So it looks like the multiplexer was probably the easiest one, and then you'd have to decide between the decoder and the basic gates.